Hi, good afternoon. It's Jim from maverickstar Observatory, and it is the 17th of the month, and we all know what that means. If you follow the channel, you'll know that on the 17th we take the latest magnetic pole position and we put the longitude and latitude on Google Earth Maps so you can see the distance it's travelled. And in this episode of following the data over the months, we're going to show you something a little bit different. We've tried a new thing, and it's paid off to some degree. If we look at it along the terms of low band, high band and ultra high band, which is the way we collect the data, and just make some comparisons so that you get an idea. Usually we collect 300,000 readings in the month. We've tried high band, where we collect more data and compare it, and we get a better resolution of data. And first of all, you can see we've collected over 600,000 individual sets of data every 3 seconds. And I want to explain something. We can't go ultra high band because the CPU just can't handle the amount of packets of data every 3 seconds that are coming in from 3 tracks. It does collect off the 3 tracks, but to get a comparison of equally weighted data off each track is very difficult. We can do low band, which is what we usually do. We can do high band, which we've recently found out we can do, but we can't do ultra high band. It just puts the processor behind and starts to fail, just simply because it can't handle the amount of packets of data that's coming in every 3 seconds. The way we've got the system set up is we've got 3 individual tracks measuring X, Y and Z axes, and then it compiles the data for the heading off all 3, and then writes it to the SD card for us. But it just simply can't handle doing it off every track at the same time. Yeah, it's just a fault in the processor speed. We could probably get a better grade computer at a later date. If we get a big chunk of funding, we can do that. But we're managing on what we've got, and we're getting some really good results. Electronics fail, and we've got a bit of bad news. The magnetosphere data failed to write even a single packet of data, so we've got to have a look at what's wrong with the magnetosphere equipment. But it should be up and running. What I'm going to do is do a few diagnostics on it later on in the week, and do a 7-day reading at some point, just to give us some data as soon as possible on the magnetic field strength. But let's explain what we're looking at here. You might notice on this high band resolution that the sine wave starts off bigger than what it finishes, and it also finishes higher at one end on the right hand side than it does on the low hand side. You know what that means? Simply, it is covering more distance over a shorter space of time, which we're going to have a look at on Google Earth, just to simplify it for you guys. I know some of this stuff is a little bit high tech for you. I lose some people talking about it. I try and explain it in the simplest layman's terms for everybody, so we all understand what the equipment does and how it works. But this is something new that we've tried. We're getting twice the amount of data, running it at high band. I don't know how reliable it will be to continue doing this, but it's just pushing it a little bit further so that we get more resolution out of the data, and we pick up anomalies like we see here. Around the 140,000 mark, you'll see an anomaly, and I don't know what that is. We don't usually get that anomaly. Maybe it's just a glitch because we're running high band, and it has failed at one particular point, but it doesn't matter because the integrity of the 640,000 readings is as we would expect to see. But yeah, it's an unusual pattern that we see when we're running at high band, because we can see the sine wave at the left hand side of the chart running slightly higher, fluctuating probably between 2 microteslers, and when it gets to the right hand side, we see it running very close to 1 microtesla, but at a higher level on the left hand side of the chart. So what does all this mean? Let's go over to Google Earth and have a look. So you're all waiting for what is the speed over distance, and has it broke any records? Well, I can clearly say yes, it has. It's covered more distance in the last 30 days than the magnetic North Pole has ever done. It's covered a distance in 30 days at a rate at 5.44 miles over the 30 days, and that is the highest that we've ever recorded. For those of you that are following it on your own Google Earths and want to know the latitude and longitude, it is 82 degrees by 57 hours 51 minutes 82 seconds north. Longitude is 121 degrees 22 hours 14 minutes 14 seconds east. But let's have a look at what this actually means when we zoom out and have a look at how things are progressing. Yes, we know it's covered that little bit extra this month than it ever has done, so things are progressively increasing. And you know, there's another thing here. We are approaching that 40 degrees and we're not that far away from it. Let's have a look. So zooming out, we'll be able to see exactly where that is in relationship to where it's heading and how close it is to the 40 degrees mark. And you can see the corridor, and it is tracking directly towards the 40 degree mark and is still on course for Russia. And you can see all the pins on its current heading over the last 100 years. And it's heading towards this little marker here in central Russia. And I don't think it's any excuse any coincidence that, you know, Russia is marked up as one of the spots for the least precipitation in the future. We're talking when it, you know, obviously there's been some research done since 2015 which extends to forecasted 2030, but is current at this moment correct as far as I'm aware, and it shows that Russia's very least likely to get floods. You have to ask yourself the question, is it a coincidence that over the Arctic Circle we have the Arctic conditions weather-wise, we have a magnetic pole, we also have a rotational axis, and two of those things are starting to leave that region and migrate towards where the highest intensity is over the northern hemisphere, which is Russia. And we know it's heading here, central Russia, because this is the epicenter of that highest magnetic intensity. We know also that Canada is losing its intensity, and that is why over the time of the last 100 years it has begun to migrate from Canada, where it was settled for the last 780,000 years, to the current point in time where we are at, which is very close. And this is another thing that I find you know, unusual. Look how close we are to the North Atlantic Ridge. We're on top of it almost, and you know, our predicted 40 degree mark is where we enter the wheat field lines, is not just too far away from it, it's on the other side of the Atlantic Ridge. Does it have some major key mechanics playing in the magnetic reversal, that Atlantic Ridge, that big crack in the crust that runs from the north to the south of our planet? I guess we're just going to have to see what happens from this point on out. We are merging very close on that 40 degree mark. Another hypothesis is that I've had is, you know, when we get to the 40 degree mark and the magnetic poles go into the weak field lines where things start to accelerate, at that point will we start to see a magnetic pole excursion faster than what we've been used to seeing? Will we also see the Arctic climate moving faster? And will we also see at that point a rotational axis shift? The reason why I ask this question is we can compare a lot of sites around the world, like Egypt's pyramids, with the magnetic North Pole. They was aligned up perfect with the magnetic North Pole, and to date there has been no shift in the rotational axis. But this is something that science has said is perfectly feasible. But what is the mechanisms that set up such an event, and why is it important? Well, I'll just explain one thing. Around the equatorial region of our planet, because of the rotational axis, we have what's called a superbulge of ocean. And if the rotational axis shifts, so will the superbowl of oceans also move. And that could flood land, it could extend coastal land, and obviously, if it happened quickly, would cause complete devastation globally. And this is something that has scientifically been accepted as feasible. We don't know what the events lead up to that sort of event, what triggers that event off, but it's feasible. I just want to go back to a few moments when I said to you, we got three things which I don't believe is just by coincidence over the northern and southern hemispheres, and that is the magnetic poles, the Arctic climate, and the rotational axis. My question to you is, are they all linked in some way? And we're never going to find out if we go back into the historical records, because we have never, as a species, been through a completed reversal, simply because of the fact it was 780,000 years ago that this event last happened. There is no recorded data. We're probably one of the only observatories recording it at the resolution that we are in the world, and that is solely down to just a few people. I said in the video that I've done this morning, just announcing the work that we're going to be talking about today, that it is a real shame that 15,000 people visit the site every week where we upload the trimag data and the magnetosphere data, but we only have one or two people donate a couple of quid on there. We have more people on YouTube that hit that donation link down there than we do that on the website where we actually publish the data. But we don't get 15,000 views every week on YouTube for some reason. And yet we are the only observatory in the world recording this at the resolution that we are. And today is a very special day because we have gone high band on the resolution, so we've uploaded onto the website twice the amount of data that we usually do. That's 600,000 data packets compiled in a chart for you to have a look at the progression of the magnetic North Pole, the rarest event in human history, which is changing everything. As you know, if you've been following, this is pumping more radiation into our atmosphere, not just because of the magnetic pole is reversing and the magnetosphere is weakening, but because of a low solar output, which is shrinking the heliosphere, which protects our whole solar system. So our primary and secondary defences are weak at the same time. This is a double whammy, and of course the effects are multiplied because they are both happening at the same time. So all I can do is just hope that more people support what we do, and we can cover it in greater resolution, in the coming days, years, and record the event as it happens in the highest resolution that anyone, I suppose, could physically and possibly do. But it does require some funding, and that can only come from you guys. The reason why we're not approaching organisations for funding is because we're keeping it as honest and openly as possible. And of course, if you're relying on corporate funding for such a thing as this, there is obviously margins for corruption, and that's why it is expected really of the general public and our viewers for them to occasionally, time from time, to support the observatory with a little bit of finance. So I'll leave it there, guys. Another record broken. We've covered more distance in a shorter space of time. Things are starting to warm up, aren't they? Links down there in the description. There's a link on the website if you want to help support us there. And as always, take care of your loved ones. We'll be back again in a few days with Earth Health at a glance. But till then, as always, bye for now.